We are recording again. So let's wrap this discussion up with this struct and typedef struct, how we do this thing. So as we said, there are multiple ways of using struct depending on actually what you want to achieve. You can make use of struct for one-time use, multiple use with without a type definition, or with a type definition, where you can actually refer it again and again with the type, alias type name, as we have it here. But when you have a named struct, you have to use it alongside with the struct s, struct keyword. And this also allows you to do actually recursive definitions, as we have seen here in this example. This type of definition here allows you to actually use this definition again as a recursion inside the block where you define your structure. Okay. So this will be useful later on as we go into these dynamic data structures, like let's say, like linked lists and so forth. So keep this in mind. These are the possible ways of using structs with or without type defs and with or without naming those structure types that you want to actually create. All right. So and of course, you can, for example, if you have defined it like something like this, and later on you can reuse that name or redefine that name for some other purposes, because this name is only existing within the context of struct, right? So it is not bound to anything, so you can use it anywhere you want. Again, of course, not a third time, but a second time you can use it. So this is, again, for you to understand this naming of structure types and how you use typedef. Typedef is just an aliasing. And if you want to use a named struct, you can define a name for a struct without a typedef, but you have to use that name along with the keyword struct all the time. Okay. So this is kind of this wraps up the discussion with structured types. I want to do some examples in the next 50 minutes or so. So this example is going to be a simple one. And what we are going to do is we are going to take a problem, and I have my problem defined to be simple 2D geometry. This is going to be something relevant to your project, upcoming project, which you have been discussing with your with one of the TAs from last week. And so that this is kind of referring to that project. And I want to start with just a simple representation. How would I represent, let's say, geometric entities in let's say in C, with using C, and how I can use in specifically how I can use structures to achieve that. Okay, so let's look at first of all, the concept. This is something we have discussed before. If you recall, we talked about abstract data types. And what I want to do now here is I want to actually create some abstractions, or I want to create a data type for 2D geometry. And the first simple, let's say, type of data that I would see in a 2D geometry is points. A 2D point lies in a two-dimensional space. In this case, I have X and Y. You can see this is the X-axis. This is a simple representation. It's a Cartesian representation, right? And I have this X-axis here, and this is the Y-axis, all right? And any point in this representation is here, a point is here, is a dot in this space, infinite space on both directions. And it is in Cartesian coordinates, it is represented by two numbers. First number is the number that actually how far away this point from your center in the x direction, and also how far that point is from you from the y from 0 in the y direction. So this is called the x and y coordinates of this point. And this is known facts. You know this from simple geometry, trigonometry, or whatever you have studied in maybe in high school or maybe in your math or calculus classes. Okay, so what I want to add to this one is perhaps I may want to also name my points, name my 2D points. In this case, I have 4 points here. I named this one as A, and this one as B, this one as C, D, and C. And these are the points that I want to actually have. So for a point to be represented in C, I may need a name for it. And then I may need 2 coordinates, X and Y. In what type of values are going to be these? These are going to be floating point numbers, right? So I can have real numbers. Since this is an infinite space here, infinite line here, any point here is going to be represented probably with a real number, right? So this means that in the representation, I should have a double or something like a float number for X and float number for Y, and a character array or a string for the name of the 2D point. All right. So this is a simple concept, points. Okay. Points alone probably doesn't make any useful things in 2D geometry. I will need some other things. I will need, for example, I may, points alone represented this way is not going to be very interesting. I may have, let's say, other things like I want to actually move 1 point from one location to another location. So in this case, what I'm doing is I'm taking point A from this location and putting it in this location and renaming it perhaps, or making a copy of this point and moving it from one location to another location. So this could be an operation. Or I may be actually moving the same point from one location to another location. Perhaps in this case, the naming doesn't change, right? So how do we do this usually? The location of the first point is this. It is actually increase in two X and Y direction by some amount so that I can get the new one. So XB is the coordinate of the first coordinate, X coordinate of the first point plus some displacement. And YB is the new points, the new location of the point is the old location, the old location or old Y location plus some displacement in the Y direction. So this is a very well known fact in trigonometry, right? So this is one possibility. Another possibility is that I can take this point and I can rotate this point, assuming that there is a line connecting this point with to the center, and I can rotate it some degree. And the way that I actually do this, there will be a new location of that point after the rotation, and it is this way. It is XP is simply cosine theta. This is the angle of this is the angle here. In this case, theta is 90. Cosine theta xi plus minus the sine theta. So this is sine theta by a, and then YB is sine theta xa plus cosine theta ya. All right, so this is how you actually will do it. So this is some operations that I can actually do on points. All right. Another geometric entity in 2D geometry could be a line, a line or a line segment, for example. I can talk about, in this case, I should have a line segment here. A line segment can be actually thought of a line between 2 points. So I have 2 endpoints, and then I have anything in between that I connecting these 2 points with the shortest line is my line. So this is the definition. This could be the definition. You can do actually operations operations on points as well as lines. So 2D point operations, I may need to have an operation to create a point. So how do I create a point? How do I actually create the point for the first use? I may want to print it so printing could be to a console, or it could be also to a, I don't know, canvas, to the canvas, right? I don't know this one, but I can, at least I know this one for the time being. So I can copy it. I can copy one point to another variable, or make a copy, duplicate them, right? I can translate a point. I can rotate a point. I can find point distances between 2 points. So this could be useful. So if, for example, here, you may want to know, okay, how far is this point A from point C or B? You can actually know this one. You can actually go and actually measure it. And there is a simple measurement for this one. You take the coordinate differences in X, square them, and coordinate difference in Y, square them, add them up, and take a square root of that. This is what we call Euclidean distance. All right, so these are, again, known facts in 2D geometry. For 2D line segments, you can have the same type of things like creating a line, printing a line, copying a line, translating a line, rotating a line, finding the angle between line and the x-axis. So for example, if this is your x and y axis, and your line is this one, you may want to find, for example, this theta here. What is this theta? So how is that line oriented? Or you may want to have also, let's say, the length of the line, for example. You might want to say, okay, what is the length of my line, right? How long is it? You may want to have, for example, when you have two lines, unless they are parallel, they will intersect at a point. So you may want to find the intersection point between two lines, intersecting lines, and so forth. You may have a lot of these things. So this is kind of a, let's say, a summary of things that you might need for a basic 2D geometry algorithm, or not algorithm, a library, to do useful stuff in 2D geometry, right? So these are the kind of the data types that we discussed, a point at the line, and then operations on these, okay? So let's go back to the first one and say, okay, how do I represent a line in, let's say, in a point in C? So someone tell me, how can I represent a point in C? Someone. How can I do it? We use structures, so it will be struct a 2D array. Okay, so someone is saying, let's do a 2D array. So for example, is saying double P2. Okay, so this is a 2D array. And I know that P0 is going to be the X coordinate and P1 is going to be the Y coordinate. Okay, this is a possibility. What am I going to do with the name? I want to name my point. All right, so Hussein, answer. No, Atakan answer. One this struct array. I said 1 point. So Hussein is saying let's use a struct. So it seems to be a reasonable way also. So if I didn't need a name, then this will be a good way to do it, right? But if I needed a name, then I would have a struct, right? And I will have a character something, like for example, name, 10 character long, and then double X and Y. Okay. Now, one of the things that perhaps using a struct this way instead of this one could be a little bit, struct could be a little bit better. Why? Because the naming convention here, this X and Y, so P of X and P of Y, PY, PX, this actually suggests you something. You can use this name for suggesting that this is the X coordinate. Here, Atakan needs to know 0th index is the X coordinate and first index is the second coordinate, the Y coordinate. Here, you don't need to assume that. You know the name of it, you just use that name. P dot X is the X coordinate, P dot Y is the Y coordinate. So sometimes this type of structs can actually help you understand what is going on with your data. So in many cases, when you have structs that actually are composed of same type of values, then you can do them with arrays, of course. But even in that case, structs can be useful because it allows you to access the name with the name instead of with an index. Indices are 0, 1, 2, 3, 4, right? But names are suggestive. They suggest something. So you can use the suggestive names to tell your, let's say, programmer to what it means, what those fields, individual field means. So one of the reasons that we might use structs in this case is because of that suggestion that name can bring. Okay, let's go back to, okay, so this is fine. How about 2D points, 2D lines? How can I actually represent 2D lines? Someone tell me. How can I actually represent 2D line? One 2D line. I'm not talking about an array of them, but just a 2D line. How can I represent someone? How can I represent a 2D line? Remember, a 2D line is composed of two 2D points. 2D struct array, 2D struct array. What do you mean by 2D struct array? I said, okay, maybe I should tell you this. So one thing that I'm gonna do is, where is my code? What happened to my code? All right. Maybe I just got it. Let's go back to here. So this is one possibility. I hope you are seeing my screen. So this is here is a 2D point. It's a struct. It has a name. 20 characters long. Maybe this is too long. I don't want that many possibility for a naming of a point. And I have this X and Y coordinates. Okay. So if I have a point defined, for example, if I have a point defined P2D is first point or point A. Okay, that's not right. So this one, when is this called this way? All right. So point A, I can describe something like this, and then I can say, okay, A of X is my X, A dot X, and A dot Y is my Y coordinate. So this is one possibility. Okay, assume that this is the case. How about the line? This is a 2D line. How can I actually represent a 2D line? What, you recall that we want to actually give a name for the line, perhaps. The name is this. I want to name everything. I want to name my line in 2D geometry. And then what do I need? I need 2 points to define the line. One start point and one end point. From start point to end point, right? So if this is a line in 2D, this is a start point, this is end point. So I need 2 points. So let's do it this way then. Point 2D, I need 2 points, and start point and end point. That's it. So start and end point representing the line. So this is fine. Now I have a simple representation for keeping a point data, point 2D point data in P2D, and then L2D is going to give me a line data. Okay, so let's start with a simple thing. This is how I would actually write a print a point. What am I doing here? I'm saying, okay, a 2D point can be printed using this function. It requires a pointer to the point itself, and then it will just actually point it. First, it will print a name like this here, name, and then it will actually print within a square bracket, separated by a comma, the X and Y coordinates. So this is the X coordinate of the point and the Y coordinate of the point, and this is the name of the point. So let's do a test case. So these are my 3 points that I defined. First point is labeled A. The name of the first point is A. The X coordinate is 10. The Y coordinate is 10. The second point is P2. It's called B. 4.0 is the first coordinate, 3.0 is the second coordinate, and so forth. When I try to actually print it, the first print function that I wrote wanted to have a pointer to my point. It requires a pointer, so this should work. Let's actually make sure that it works. Let's see. This is the compilation. I did a lot of different things here, of course. I need to make sure that this is the first one. This is not going to be right here. Let's do this one again. Now, if I actually do this one, test exit, I have this one. Okay, so this is how it is printing. So if I print the next one, I can print the next one and so forth. Now what I want to do is I want to have another one where I want to actually, so another possibility of this one, instead of sending the pointer, as I have it here, you can send the copy of your point. Not a pointer, but a copy of the point. Okay, this is a possible one. And I can actually use now, when you send a copy of it, I use dot here, if you recall, p.x, p.y, and p.name. And we didn't prefer this one usually. Why? Why was the reason that we are actually not preferring this? Okay, I see that there is a delay. I'm gonna slow down a little bit, but the question is, there are two possibilities of sending your point to your print function. One is as a pointer, the other one is as a normal argument, copying the thing. So which one? We usually prefer the pointer over the other one, and the reason was, someone? The reason was, okay, the copying takes time. It is expensive in terms of things, and Merve is saying that this is kind of as instead of doing that, do it by reference. This is not exactly reference, but anyway, so we have been discussing that. We'll discuss it for further. So this is not preferred, so I'm gonna get rid of this guy here. So I'm not gonna prefer to send the copy of the thing for printing. Rather, I will actually send just a pointer to it. Let's say that we actually want to do an array of points. I may have an array of points. Why? Because one point is not going to be interesting to do anything. Maybe I need, let's say, lots of points. I want to have lots of points in my let's say geometry, right? So in that case, if you are sending me an array, what do I need? I need to know how many entries you have in that array. How many points do you have in that array? So once you give me that, I can actually just print it using this thing. So for each of these, just print them. All right, an array of points. Okay, let's do this for a 2D line. So I can think of this. I can do this in two ways. I can say, okay, 2D line is actually, I have a start point and an end point, or I can actually say, okay, just say here, print f my line, and here perhaps something like this. Okay, and then the name of the line, the name, and then I can call just p2 print the first point, which is the start point, start, and then I can call the thing for end. Here, let me wait for a while so that you can see this. So what I did is, for printing a line, I print the name of the line, and then I print the start point as well as the end point, one after another. So this could be one way of doing it. Perhaps you may want to do something else, perhaps, but I don't care. So this is one way. Or you can actually print them one at a time. So you can print them here. You can say, okay, the endpoint, and then so maybe the alternative to this one could be something like this. Let's say. So I say, okay, this is the name of the point. The start point is this, and the end point is this. So now I want to actually print this exact thing here. So this start point, and this is the end point. How do I do this one? I will say L, S, X. L, S, then L, S. So this is another way of doing it. Let me wait for a while so that you see them. So instead of actually printing the name of the line and then the two endpoints, I want to print them specifically in a different format. Here, the name of the line, and I'm going to forget about the name of the points, endpoints. Just print the coordinates of those two endpoints, one after another, using a comma separated thing in between. So this could be one way. This is not very neat. This may have some problems because this requires for you to access the start point and the X coordinate and the Y coordinate. So since I have already a printing function for my point, then I may want to use actually the alternative version that I have here. Okay, good. Any questions? No. So if I have a print array, then I can actually just, as I did here, print array would be, of course, a print array requires an integer number of, and I need to know how many entries you have in that array. And this is gonna be the same thing as I have it here, right? So this is gonna print line. So just line here. Oh, okay, actually I need to go back to this print array thing again. There are two possibilities there. Okay. Here, let's look at this print array function again. I am at line 31 of my code. Are you able to see that? Please let me know. Are you seeing what right now I'm trying to explain you this point to the print array function at line 31. Do you see my screen? Yes, all right. So here you can see that at line 33, I am printing the 2D points in that array. And then I say print array to the point to the print, P2D underscore print is called with P plus I. So this is originally it is supposed to be this way. I need an address of what? P, the ith entry of the array. I need the address of the ith entry of the array. So I take the ith entries. I have first, second, third, and fourth, and so forth. I take one of those entries, and I send this entry's address to my print function so that it can print it. All right. So this is the proper. This is one way of doing it. This is possible. Another way of doing this is simply this way. I know that my starting address, if I send it this one, for example, just print P, it will print the first entry, right? This is the address to the first entry. But if I actually just add here I, this will say, take the address of the first entry, add this one some number, the ith number. What this will do is this will do the same thing as you are taking the indexed, the ith entry of the array and sending the address of it. We are going to talk about this one tomorrow a little bit further when we talk about pointers, but this is a simple operation where I am actually starting from the first entry and incrementing in I And as I actually increment I one at a time, I'm going from the first entry, the second entry, third entry, fourth entry, and fifth entry, the address of the first entry and second entry and third entry and so forth. So this is how I would do it. Of course, if I'm able to do this one, I can do a little bit better coding here. I'm going to come back to this later on. But for the time being, this is good enough. Okay, the same thing here. What I am doing here is that on line 48, I'm taking my line to the print function. I'm sending to it a reference to a line, and I will start from the line array from the beginning, and I will go for one at a time. So if I do this one ls, perhaps the line here, that will be easier. Maybe I should have done it this way. So this will be a little better. Point array and line array here. All right, good. So this is one. This is for printing. Okay. So let's talk about another thing. So what can I do? For example, I want to do given a point, I want to translate a point. So if you recall here, translation of a point meant that we take the point from one place and move to another place. So I can have different versions of this. One version could be this way. Just let's say, what I want to do is, not this one, perhaps. I want to do this one. So what I want to do is, I will take my original point, okay, and I will translate it by a double X amount and double Y amount. This is what I want to do. You give me the how much translation you want in X direction and how much translation you want in Y direction, and I want to move that point to that location. But I want to update the point's new location. I don't want to copy the point and create a new point, but just take the same point, just move it around. Okay. Now this is very simple, right? So how do I do this one? So someone suggests me a code segment to do this one. So I give you a pointer to a point, and I give you the double X amount and double Y amount to move it in X and Y direction and get the same point, but at a different location now. So how would you do it? Type me a simple code segment, or just let me know, speak up. How would I do it? Come on, people. Are you with me? Anybody? Did I just lose you all? I'm hoping that this will help you. Soruyu anlamadınız. Okay. So let me go back to here again. This is, I'm going to do a little bit slower this time. At line 51, okay, I want to write a function to translate a point from one location to another location. You give me 1 point, just let's say your point A is here in your 2D domain. I want to move it in X dimension and Y dimension by sum and move it over here. So my function is taking a pointer to a point, 2D point, and it is taking more arguments, the two double arguments, X and Y, indicating the amount of translation that I want to have in both directions. And I want you to actually tell me what type of a code, what should I do? How should I actually do this in code? All right. So apparently I need to update my coordinates of my point. The coordinates of my point is P arrow X and P arrow Y. I need to update them by how much? X and Y, or delta X and delta Y, if you want to actually X or TY, translation X and translation Y. So this is gonna be simply P arrow X is moved by TX amount, and P arrow Y is moved around by in the Y direction by T of Ty amount Ty. So this will actually translate my point from its original location to a new location, which is going to be defined by Tx in the X dimension and Ty in the Y dimension, right? This is one possibility. Okay, let's look at another one. This time I want to actually rotate my point around the X, around the origin by theta. So this is this case here. If you recall this one, I want to take my point and rotate it. So this is my point here. This is where it actually connects to the origin. And I want to move it from here to here by theta amount, right? So I have given you the code for this. It actually uses cosine theta and sine theta. So the way that I'm going to do it is this one. This is very simple. I'm going to say, okay, now I will define X and Y, my current values. X is P of X, Y is P arrow Y. And then my new X is gonna be simply cosine of what? Theta times, if you recall here, it is cosine theta X minus sine theta Y. And P of Y is, Py is, the Y entry is gonna be sine of theta times X plus cosine of theta times Y. This is taking my original point, rotating it around the origin of my coordinate system to a new point. Again, why did I actually make a local copy of the coordinates X and Y? Why did I make a local copy of the points X and Y, the coordinates X and Y? Can someone tell me? All right. Why did I make a local copy of point P arrow X and P arrow Y? Okay, so this answer was good, but someone? Okay, nobody is. So is it so much delay that you're not getting my questions, or you are? Where are you, people? Feedback. All right. So the question is, if you see the code at line 56, the function starting at line 56, what I did is I actually make a copy of the original location of the points, X and Y locations, in a local variable. Why did I do that copy? In above code, I didn't do any copying, but here I'm copying it. It's very simple, right? So if I didn't copy it, if I actually directly assigned, or so let's say if I use here P arrow X, then this P arrow X is gonna, and if I do it this way here as well, the P arrow X is gonna be updated here. So I'm gonna have a trouble when I try to access the old values. So old values has to be kept in place. Okay, what else could I have? For example, one thing that I might want to have is, for example, if the distance between 2 points. So I want to have a function void p to d distance. And for this one, what do I need? I need 2 points to find the distance between them. So there is point 1 and there is point 2. So the question is, should I use a pointer to these or copy? It makes sense to actually use a pointer. And the distance between 2 points is actually simply given by their coordinate difference in x and y squared, and actually just add it up together and you get a square root of it. All right, so this means that I want to have a dx, which is p1 of x minus p2 x, the x coordinate of p1 minus p2. This is the difference in y x direction, and in the y direction is gonna be p1y minus p2y. So these are the differences in x and y directions, and the definition says first square these terms, add them up together, and then get a square root. So the answer is gonna be return. Of course, this is gonna return a value, which is gonna be a double value, and return the square root of, there is a function called square root in math library, which will take this sum of dx square and dy square. So this will be my answer for distance. So given 2 points to me, I will give you the distance by taking the differences in x directions, x dimension and y dimension, and then just square those and add them up and get the square root of it. All right. So I can continue writing this thing up. So maybe the last thing that I want to do is perhaps, let's say, I have all these. Now I may need to have a 2D line translate, a 2D line rotation, and so forth. So all those functions that I want to have, I may want to have it here. So what I will do is I will let you have this code to have a look at. And next week we are gonna, it's not next week, tomorrow, right? So we are gonna discuss a little bit in the beginning of the class tomorrow what we have here. If you have any questions, we'll go over them. Otherwise, we'll talk about this pointer stuff that I started to kind of discuss right now. So, any questions? Good. Any questions? Did I miss any questions in the meantime? I may have. I think I had missed a question. There was a question about. Someone was asking something about something. Where is it? This one here. So Mehmet Avni was asking if I use, how do I use actually? Okay, let's actually answer that question here very quickly. So assume that we have let's say a type def. Let's do a type def, and this is a union type. And he's about saying, okay, let's have a character C, and integer I. So this is the type that we have. This is IC type. Okay, or this is my IC type, and I have a function void. And he's saying he wants to read something to this. So he has an IC type variable this, and he wants to read something to this variable. The question was, how can I read? What do I do when I read something to this thing? So if I am doing, let's say, fscanf here, or scanf, so let's do a scanf. So I'm gonna define a thing, and I want to actually give this thing here. So the question is, first of all, you have to decide which one are you reading. Are you reading an integer or are you reading a character, right? So you don't know. If you want to actually leave it up to the user, one thing that you might want to do is maybe you want to do it this way. You want to say, okay, printf select I for integer or C for character input. So you might want to say to your user, okay, I want to know which one you want to actually get. And then perhaps I want to have jar response here. And then I will say, okay, once you actually have that one, I'm going to scan that from you. My answer now, this is R. Now, looking at R could be either an I or a C. And if, or let's say switch R, and if it is I do one thing. If it is C, I do another thing. Now let's look at each individual cases here. So if the user wants to enter, give me an integer number, I'm going to say, okay, I'm going to read an integer to what? To my this guy here. This is going to be an integer. So if not, if the person wants to enter a character, then I will read a character here. Now, the answer to your question, Mehmet, right? It depends on what the user wants to enter, right? You need to check that. You need to make sure that you have a check to get its the user's intention. In this case, I am assuming that I can answer a question, ask a question. I ask the question to the user. Do you want to enter an integer or a character? So, and then he says, okay, yes, I want to enter an integer. Then if he is entering an integer, I'm actually putting this thing here. I am reading it to my integer field of my union type, a union variable. If the user said she wants to enter a character, then I'm going to read it to the character part of character as a character in my union type or union unit variable. There is no other way. I cannot just say, okay, read something and assume that that is the correct thing. There is no other way. There is you cannot actually do it. This is not designed for that purpose. This cannot read intentions. You have to clarify the intention and actually make sure that you actually use that the proper mechanism to actually get that intention in to the code. So this is a kind of the long answer to your question that it depends, and you have to clarify what you want to actually get. If you know that the user is always going to enter an integer, then you just use the this one, this part of the thing. If the user is always going to do a character, then you'd use this one. But if you don't know what the user is going to do, then either you ask him or her, or you actually find a way to discriminate these things. So this is not going to be done right away like this. So you have to actually do some tricks. You read the input from the user as a string perhaps, and then you try to understand or decompose that string into an answer, saying that okay, this might be an integer or this might be a character that user wanted to do. All right. All right, if there are no other questions, we'll stop here and we'll continue with this, with what I've started for this geometry for 2D points and lines. And if you have any questions in the meantime, please let me know or ask them tomorrow in the first half of the class. But please look at this code. I'm going to put this code right now in our Moodle page. And have a look at it and study it and let me know if you have any questions tomorrow. So I wish you all a happy and safe day.